here are some of the questions that we can solve under binomial. So the first question reads, the independent term of x in the expansion of, when we expand this binomial, then to the power 9 is, so the independent term we have is this number that we have there. So they're saying the independent term, mean the term without x, when we expand this binomial, is 61,236, where k is a constant. Find the value of k. So they want you now to find the value of k. So questions like this, they're saying if you have a binomial k over, then we have x squared plus x, that's a binomial we have, to the power 9. They're saying when we expand this, now when we have all the terms in this expansion, now the term which is not going to have x, which is independent of x, is going to be what? It's going to be equal to 61. It's going to be 61, then 236. That's what we mean. That's what they mean by doing that. So how do we answer these questions? And we have k here. So we take this binomial we are given into the normal one that we know, a plus b to the power n. So our a is this whole thing here, that's our a. Then this is our b, which is x. Then our n is our power, which is 9 there. Okay, so now let's solve this question now. So we'll now say, using a general term. So I said when the questions like this are asked, you don't have to expand this binomial. Just use the general formula, which says tr plus 1 equals to, now we have n combined r, then we have a n minus r, then b r. Now when we use this one, so this is the whole term and it's given in this case. So our term, the whole term which is independent of x, like I said, this is used to find the coefficients or the terms which are independent of what? Independent of x. That's the use of the general formula. So now we say t plus r plus 1 equals to that. That's the formula for the general term. Then we can now get and substitute the value. Now, do we have r? Where r is the position of the term. If they said the fourth term is 5, now they didn't say anything about the term, the position of the term. They just said the independent of the term of x in the expansion of this is that. Meaning they haven't told us if it's the fourth term, fifth term, sixth term. Meaning if they haven't specified like that and you're using a general formula, you have first to find the value of r, the term. After that, then you can now find what you were asked. So now say, let's expand. So say tr plus 1 equals, we need first to find the value of r. So say now r, n combine r, then our a is k over x squared, everything to the power. Our n is 9 minus r, we don't know what the value of r is, times our b is what? Our b is x, sorry. So our b is x to the power r. In this case now, according to the laws of indices, we says if you have a over b to the power n, this is a to the power n over b to the power n. This n distribute for the powers of these guys too. So then we're going to say tr plus 1 equals to n combine r, we don't know what these values are, then this can now be k, this 9 to the power r can be for k, then 9 minus r over x, then this is the power to 2 times this power, we're going to have 18 minus 2r for r, then we have x to the power r, like that. Now in this case, since we are talking about the term independent of x, meaning the term independent of x, if you have 2, I said this can be equal to what? 2x to the power 0. So when you have the term which is independent of x, it means that x is what? There is the power 0. That's what it means. So in this case, then we're going now to have, or to use, sorry for that, then we're going now to say, take only every term or every part of this function that you have which have x only. So now say tr plus 1 equals to, Then we're now going to have n combine r. Then we'll remove this k because this k doesn't have x, so take it as k 9 minus r, then multiply this by, then we get x to the power r over x, then 18 minus 2r. So when you have a over b times a over b x, you have this can also be written as x over b, then you multiply everything by a, because you multiply x times a to give us a x, again still the same. That's what we've just done here. So this is multiplying with that, this times that, but it's the same as you remove this, take it on the other side, then you get this one, yes, upon more. So this times this, it will give us this times that over that. Now after that, then remove this whole thing which doesn't have x there, so that we can now just say we just want to remain with x independent, or in the term independent of x. We'll remove all these things here, then we just remain with the part which has x only. Then this other side, you have to equate it now to x to the power 0, because any number, a term independent of x is x to the power 0 equals to x to the power r over x to the power 18 minus 2r. Then once you have that, this also means, according to the laws of indices, if you have a to the power n over a to the power m, if the bases are the same but the powers are different, this can be equal to, just write a, then you subtract the powers n minus m. So check, this is base x, this is also base x, so the bases are the same. So this can now just be equal to x to the power, then subtract the powers, so the r minus, then this if it punch 18 minus 2r, like that. So then we're going to have x to the power 0 equals to, then we have x, then you're going to have r minus, negative times 18, it's negative 18, negative times negative, it's plus 2r. So now we said if the bases are the same according to the laws of indices, again the power should also be equal. And if we check properly there, we'll find that the bases are x, this is base is also x, so the bases are the same. Then we can also equal the powers. So we can now say 0 equals to r minus 18 plus 2r. Then let's find the value of r. So we have 0 equals to r plus 2r minus 18. 0 equals to 3r minus 18. Then take 3r or 18 on the other side, so it becomes positive 18 equals, because it's negative, 3r. Then divide 3, so that our r can now be 3 into 18, it's what? It's 6. So our value of r is what? 6. Now we find the position of the term. R is the term. Then we can now find the value of what? K they are asking us now. Okay. So we can now say, in this case, our r is 6, and also the term independent of x they have already given us, which is now tr plus 1 is equal to what? 61,236 according to the question. So that's this term here, which is a term independent of r. So the term independent of x in the expansion of this is 61,236. So you can now just use the general formula, tr plus 1 equals to, then n combining r, then we have a, n minus r, b, then r. So this whole thing is already given, 61,236, that's a term independent of x. N combine r, this is 9 combine 6, where this r replace 6. Then our first term it's k, a it's k, then over x squared, everything to the power, n it's 9 minus r it's 6, then it times our b it's x to the power 6. So we have 61,236 equals to 9 combine r, this is same as 9 factorial, that's what this combination is, over then 9 minus 6 factorial and 6 factorial, that's what it means. Then multiply this by what? Then this other one will just be, now we're going to have k, 9 minus 6 is 3, k to the power 3 over x to the power 2 times 3, it's 6. Then multiply this by x to the power 6. Now if you check x to the power 6 and x to the power 6 cancels, because this term is independent of x, so it shouldn't have any value of x in it. Then we can now have 61 236 equals to the 9 factorial. So we have 9 factorial, which is same as 9 times 8 times 7 times 6 times, then we have 5 times 4 times 3 times 2 times 1, then multiplied by k to the power 3 over, that's what factorial means. Then 9 minus 6 factorial, which is 3. So we're going to have 3 factorial, then 6 factorial. So we're going to have 6, 1, 2, 3, 6 equals to, then we have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, then k to the power 3. Divide this by, this is 3 times 2 times 1, that's what 3 factorial is, times then 6 times 5 times 4 times 3 times 2 times 1. So we can have 3 cancels with 3, 2 cancels with 2, then 1 cancels with 1. Then we have 6 cancels with 6, 5 and 5, 4 and 4. Then we remain with 2 and 3. So we're going to just remain with 6, 1, 2, 3, 6 equals to. Then we remain with 9 times 8 times 7. 9 times 8 times 7. Then k to the power 3. Divide this by so k to the power 3. Then 3 times 2, which is we only have 6 there. So then we can now calculate this now. Say what is 9 times 6? So we use a calculator. We have 9 times 8 times 7. Just want to be a bit faster. 9 times 8 times 7. Then we're going to have 502. Then divide this by 6. So this into all these numbers, we're going to have 61 236 equals to 84k to the power 3. So then from there, we can now find the value of k and say we have 61 236 equals to 84, then k to the power 3. Just divide the 6 into that, we have 84. Then divide both sides by 84, divide both sides by 84. So we are now have the value of k to the power 3 equals to, we have 61 236, then divide by 84, we have 729. That's what we have. Then from there we need to find now the cubic value. So we have k to the power 3. To remove that, find the cube root of 3 equals to, also find the cube root of 729. So this and that cancels. We now remain with k equals to, then cube root of that, shift, then the cube root of 729, we have 9. So the value of k is what? 9. So that's how you can find the binomial using the general formula. Let's also solve another question. Okay, I believe you are getting the concept. Okay, so let's also deal with question 2. So question 2 is saying, let's deal with this other one question on the same thing. Find the fourth term of x plus c y to the power r. So they're saying find the fourth term of, we have x plus y to the power 8. Then saying find the fourth term. So where r in this case is 4, they've already given us the position. Then our n in this case is the power, which is 8. Then we want to find the fourth term. So now just say t4, which is the fourth term, equals to, you just have to use the general formula again when question like this comes like that, apart from the way that question came. So you can now just say n combine r, then you have a n minus r b r. So the fourth term equals to, so say r plus 1. So now say t 4 plus 1 equals to, so I want to find the fourth term, what am I doing now? So we have fourth term here. So our fourth term in this case will now be, our n is what? 8. So 8 combining 4, which is our r. then our a is x. This is our a, which is just t. Sorry, we have x to the power, n is 8 minus r, it's 4. Then our b, we have it's y to the power 4. Then we have t to the power 4, then n, which is 8 factorial over 8 minus 4, then factorial, then 4 factorial. That's what this part means, combination. Then this is in our x to the power 8 minus 4 is 4, and we have y to the power 4. So that our fourth term now becomes 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Then x to the power 4 and y to the power 4. Divide all these things by 8 minus 4, it's 4 factorial, then times again 4 factorial. So that our fourth term now becomes 8 times 7 times 6 times 5 times 4 times 3 times 2, and we have x to the power 4 and y to the power 4 over, this is 4 times 3 times 2 times 1 times again 4 factorial, 4 times 3 times 2 times 1. So that 4 and 4 cancels, 3, 3, 2, 2, and 1 cancels. Then we're just remaining now with the 4, 3, 2. Again, 3 into 3 it's 1, 3 into 6 it's 2. Again, 2 and this same 2 cancels. We just remain with 4. 4 into 4 it's 1. 4 into 8 is 2. So we now just remain with the fourth term equals to 2 times 7 times 5, then x to the power 4, y to the power 4. So our fourth term now is 2 times 7 or 2 times 5, it's 10. 10 times 7 is 70. 70 x to the power 4, y to the power 4. So that is our fourth term in this case. Then we are done like that. Okay, let's also solve another question on binomial. So that's how you go about these equations in this binomial. Okay, so now we also have, that's the first case when using the general formula, application of the general formula. So we're also asking, they're asking this question. So without expanding, find the term independent of x in the binomial expansion of this. So we're not going to expand, but we need to find the term independent of x. So we have x plus then 1 over x, everything to the power 6. So in this case, we are not given the r, which is the term, where the position of the term. So in this case, r we don't know, but n we have it 6. So we need first to find the value of r using the general formula. Then after that, you can find the term independent of x without expanding the function. So we can now have t r plus 1 equals to, then we can now have n combined r, then we have a n minus r, then b r. So that in this case now we'll have t r plus 1 equals to n combined r, then we are going to have our a is x to the power n is what is 6, so 6 minus r, then our b is 1 over x, everything to the power r. So t r plus 1 equals to n combined r, then we're going to have x to the power 6 minus r, then this other one here. So according to the laws of indices, again, if you have a to a negative power or negative 1 or negative power, this is same as 1 over a. So this is 1 over x. So this can be written when x comes multiplied by this number that's on top there, it becomes the power of x becomes negative. So this is, since this power of x is just 1, so this becomes negative x. If you multiply this times the number on top, x times 1 it's x, but the power of x changes to a negative, and the power of x is 1, so it becomes negative 1 to the power r. So that t r plus 1 equals to n combined r, then x, then 6 minus r, then we're going to have r times negative 1. Laws of indices, a n multiplied by m, this is same as a m times n and m. So that's what we're going to use there. So this times that, we're going to have x to the power negative r. Then from here we just have to get now the terms which are the x only. So, and should be equated to x to the power 0, because that's a term independent of x. So we're going to have x to the power 0 equals to then we just get now this times that, because these are multiplying. X to the power 6 minus r, then multiply this by x to the power negative r. Then we are going to have x to the power 0 equals to, when the bases are the same, according to the laws of indices, if you have a n times a m, you add the powers a, then just say n plus m. That's the concept we're going to use here. So I'm going just now to have x to the power, then let's add these powers, 6 minus r, then plus negative r. So x to the power 0 equals to x, then 6 minus r, then positive as negative is negative r. So x to the power 0 becomes x to the power 6 negative r, it's negative 2r. If the signs are both negative, you add the r's but maintain the negative sign. So in this case, if the bases are the same, then you also the powers can be equal as well. So then we can now say, to find the value of r, we can now equate the power 0 equals to 6 minus 2r, then take 6 on the other side. Negative 6 equals to negative 2r, because 6 is positive, crosses the other equal sign, becomes negative, then divide negative 2, divide negative 2, so that our r now becomes negative into negative, positive. 2 into 3 is what? 2 into 6 it's 3. So once now you find the value of r, then you can now just replace it back into the general formula. Tr plus 1 equals to n combine r, then we're going to have a n minus r b r. Then let's find now the term independent of x now. So t, where this r replace 3 plus 1 equals to, then 6, then combine 3, then our n is what? X to the power 6 minus 3, then our b is just 1 over x to the power 3, like that. So in this case, we're now going to find d, so that so meaning this term which is independent of x, it's at fourth position. 3 plus 1 is 4. So this term which is independent of x, it's at fourth position, which is equal to, then this is 6 factorial over 6 minus 3 factorial and 3 factorial, this one. Then we're going to now have this will just cancel, which is x to the power 3, multiply this by, this power is for all these two, according to a over b to the power n can be equal to a to the power n, b to the power n as well. So a power is for both numbers in brackets. So this is same as 1 to the power 3 over x to the power 3. X to the power 3 and x to the power 3 can cancel, remains 1 to the power 3. 1 to the power 3 is 1. 1 times everything is just that. So this is same as now 6 times 5 times 4 times 3 times 2 times 1. That's what 6 factorial is. Over, then 6 minus 3 is 3 factorial times 3 factorial. So that our T4 now becomes, let me write it on top here. You can now say our T4 equals to, this is 6 times 5 times 4 times 3 times 2 times 1. Over, we have 3 times 2 times 1, that's 3 factorial. Again, 3 times 2 times 1, that's another 3 factorial. So 3, 3, 2, and 2 cancels. Then we can now just mean with T4 equals to, then 6 times 5 times 4, divide everything by 3 times 2 times 1, which is a 6. So 6 and 6 again cancels. Then we'll just mean with T4, the fourth term which is independent of x is 5 times 4, which is a 20. So that's the term which is independent of x, and it doesn't even have x. That's how we solve questions using the general formula. Let's now solve question that involves now binomial expansions.